Now let's take a look at a special kind of annuity. We call this the perpetuity, which is basically perpetual annuity. So it is an annuity with the cash flows that would go on forever till infinity. An example of the perpetuities would be the preferred stocks. Those preferred stocks would pay a fixed amount of preferred dividend, or say same amount of cash flows, year after year till forever. If we want to figure out the value of those preferred stocks, it's actually to estimate the present value of this annuity. So the present value of this annuity is actually based on the present value of the ordinary annuity that we talked about in the last lecture. Here, we have the present value equals to payment multiplied by this annuity discount. Now, when n approaches infinity, then this part, 1 divided by 1 plus I at the power of n, will be approaching 0. So what you have on the right hand side would actually be 1 divided by I. So that's why the present value of the perpetuity is actually the payment divided by the interest rates. Now if we look at an example, if we do have a perpetuity that pays $100 year after year till forever, and the discount rate, or say the interest rate, is 10%, so we use $100 divided by the 10% to get $1,000. That would be the present value of this annuity. You will see this again in Chapter 8 when we talk about the valuation of preferred stocks, because again, the valuation of preferred stock is just an application of the present value calculation for perpetuity. So far, all of our previous examples and calculations are based on annual payments. We have been talking about one payment a year, but in reality, many businesses or personal situations that would require more frequent payments. For example, bonds, when they make the coupon interest payments, a lot of them they pay semi-annually, or say twice a year. A lot of companies, when they pay dividends, they pay every quarter, so that's quarterly dividends. And when you make your mortgage payments, you are paying every month, so within a year, you are making 12 monthly payments. So all these payments, as you see, are more frequent than once a year, so we'll have to discuss the implication of compounding or discounting for more than once a year. And that's why we have to talk about the compounding frequency. What you see here on the left-hand side, this is the compounding that we have been talking about. So if you have $100 compounding by 10% each every year for 3 years, then after 3 years, you will have 133.1, and that would be the future value in 3 years. So this is nothing new. We've done this from Chapter 4. And now here, if we are looking at the same $100 and same interest rate of 10% per year, however, if we are doing the so-called semi-annual compounding, and when we compound every 6 months, we cannot use the 10% annual rate. Instead, we will use half of the 10%, which is why we are using 5% every 6 months. And since we are compounding twice a year, or say every 6 months, within 3 years, we are actually compounding 6 times. So now, if you look at here, when we use 5%, the so-called semi-annual interest rate, compound for 6 times within the whole 3 years, our future value now is 134.01. When you look at these two, you realize for the same amount of $100, if we compound more frequently, by more frequently we are saying more than once a year, then after the same 3 years, we will end up with a little bit more money, or say higher future value. So now let's apply this idea and look at this frequent compounding question. So if you want to buy a car and you figure you can pay $500 per month, how much can you borrow if the interest rate is 9% per year and you pay the loan over 4 years. Notice here, if you pay $500 per month and you pay 4 years, you are making a total of 48 payments. So to calculate how much you can borrow now, we are actually trying to get the present value of this annuity. Now notice here we have a monthly annuity because you have the same amount, $500 monthly payments. So how much you can borrow now depends on how much you can pay off in the future every month, and then the interest rates and how long you are going to pay for this loan. We are using the same formula of the present value of annuity calculation. You notice the I here is the 0.75% monthly interest rate, which is a 9% annual interest rate divided by 12. And since you have 4 years, and that means you are making 48 payments. You put all these numbers together, you calculate the present value, the result is $20,092. You can also try to use your financial calculator, put this 500 as the payments, 0.75 as your IY, 48 as your N, and you can also put 0 as future value, FV, and compute for the present value, you will get the same result. Now, if you change M from 48 to 72, 72 being 72 months, because now we are looking at 6 years, then the present value results, instead of being $20,000, will be $27,738. So the idea is pretty simple. If you are willing to make 2 more years of payments, you can afford a little bit more expensive car because the present value of this loan is higher. That means the principal of your loan can be a little bit higher. So now, if we are looking at the interest rate for the whole year, we call it the annual percentage rate, or say the APR. Sometimes it's also called the nominal rate, or say the quoted rate. So for example, if the annual interest rate is 12%, that's the 12% APR. And if we do the monthly compounding, 12% divided by 12, that means 1% monthly interest rates. So if you use 1 plus the monthly interest rates and then compound for 12 times within a year, and then minus 1, you get a percentage rate that would be called the effective annual rate. So that is a rate of return that incorporates the compounding frequency. If we look at 10% APR and semi-annual compounding, or say twice a year, we plug in the numbers and we'll have 10.25%. That is a little bit higher than 10%. So we should be indifferent between receiving a 10.25% interest rates or receiving a 10% nominal rate but compounded semi-annually. So what's the big deal about this effective rate of return? When we have different compounding frequency, we'll end up with different effective returns. If you look at the effective return under different compounding frequency based on the same nominal interest rate here, you will notice that, first of all, they are all different. So we must look at the effective return or the effective annual rates to compel investment and make investment decisions. And another thing you notice is when we go with annual, which is once a year, to semi-annual, which is twice a year, and quarterly, which is 4 times a year, and monthly, 12 times a year, and daily, the effective rate actually gets higher and higher and higher. So the conclusion is, when the APR is the same, the more frequent compounding we get, the higher effective annual rate we end up with. You can also try to use your financial calculator to figure out the effective annual rate. In my financial calculator demonstration video, I also show how to use different types of the financial calculator to figure out the effective annual rate based on the nominal rates and the compounding frequency. So you may want to check out that video and then come back to this video and practice with the numbers here. So if you have the TI BA2 Plus calculator, you find the iConf function, and then for the nominal interest rate, you enter 10, which is 10% APR, and then you scroll down to enter 12 as compounding per year. So that's monthly compounding. And then you go to the EFF and hit compute. By your computation, the EFF, which is for the effective annual rate, the result should be 10.47, which is consistent to the results you have here. A very useful application for the EFF concept is when you look at different credit card offers and try to decide which credit card makes more sense to you. So if you are looking at one card that charges 16% APR and they do monthly compounding, and if you have another credit card that claims that they charge 15.5% APR and that it compounds weekly. Weekly means 52 times a year. Which card is better? The better one should be the one that offers lower effective annual rate. So the first one, 16% APR, monthly compounding, fit into the formula, and we calculate the EAR is 17.23%. For the second card, 15.5%, 52 times a year, and then you compound for 52 times, then the effective rate is 16.74%. So once you calculate the effective annual rate for both cards, you can compare the effective annual rate and decide which one is actually less costly for you, because it will let you pay the lower interest rate. Now, before we move on to the next topic, let's do a little bit more practice with this concept of frequent compounding. First question here is, what is the future value of $100 after 3 years with 10% semi-annual compounding? What if we are doing quarterly compounding? So if it's 10% semi-annual compounding, then every 6 months we are using an interest rate of 5%, which is 10% divided by 2. And within 3 years, we're compounding 6 times because we do twice a year. So the future value will be 134.01. Now, if we are doing quarterly, that's 4 times a year. So each quarter, the quarterly interest rate will be 10% divided by 4. That's how you have 1 plus 2.5%, or say 1.025. And then you compound 4 times a year. In 3 years, you will compound a total of 12 times. So when you do that, your future value will end up as 134.49, which is slightly higher than the future value under semi-annual compounding. The last topic in this chapter 5 is about loan amortization. So the idea is when you have a loan that is structured for annuity payment, then each time you make a payment, the payment will go to pay off the principal and interest. And over time, the loan will be completely paid off. And so that is actually a loan amortization process. If you have a car loan or a mortgage, you will actually get all those amortization tables from your bank or from whatever company that gives you the loan. The amortization table explains how your loan is or will be amortized over time. At the end of this part, we will show you how a amortization table is constructed. So let's take a look at the loan amortization. We are looking at a car loan of $10,000, and the loan here is for 4 years, and the interest rate is 9% per year. Usually you don't pay for your car loan by making one payment a year. You would do monthly payment. The first thing is to calculate how much monthly payment we have to make. So if we are talking about 48 months, every month the interest rate will be 9% divided by 12, which is 0.75% monthly interest rates. And the principal of the loan is $10,000. This is actually the present value of the loan. So we can try to use a financial calculator to calculate the payments of this annuity. The payment amount is $248.85. A common mistake is that some students will try to use 4 years and 9% and calculate a payment which will be an annual payment. And they try to use the annual payment divided by 12 to get the monthly payment. And that is actually not correct. We want to calculate the monthly payment based on the monthly setting instead of 1/12 of the annual payment. So once you have the payment amount calculated, we can try to understand this amortization process. What would be the interest in the first month? If we start with a $10,000 principal, this $10,000 will generate $75 interest expense during the first month. So you take $10,000 from the bank, you use the money to pay for your car, and within the first month, you haven't made your first payment yet. So by the end of the first month, you will own not just $10,000, but $10,000 plus $75 principal plus interest. And then you're going to pay $248.85. That's your first payment. So out of the $248.85, you can think that $75 is to offset the interest expense that occurred during the first month. Apparently, $248.85 is more than just $75. The extra amount that you pay, the $173.85, will be used to pay off your principal. So now, your total principal part after you made your first payment will be $10,000 minus what you have already paid off. So you only own then $9,826.15. We call this the ending balance, or say the remaining balance after you make your first payment. Now, for your second month, your interest expense will be based on this number and the 0.75% monthly interest rate. So you can go ahead, try to calculate the interest expense for the second month, and then also figure out how much principal you will pay from your second payment. Once you look at the second month, third month, and so on, the whole process, you can put them together. That's actually how the amortization schedule table is constructed. For example, the second month here, the beginning balance for the second month is actually from the ending balance from the end of the first month. So this number multiplied by 0.75% will give you $73.70 as the interest from the second month. Your principal payment part now will be this number, $248.85 minus $73.70. You will have $175.15. And after you pay off principal of this much, you can subtract this number from your beginning balance, and that is how your ending balance at the end of the second month is calculated. Another thing that you may notice is that over time, out of all the payments that you pay, the interest part actually gets lower and lower. The reason is that the remaining balance of your loan gets lower and lower, and you are actually paying more and more toward your principal, or you are paying off your principal faster and faster until the end, while your remaining balance is zero. And of course, you do not want to do this month by month manually. you can actually set up this calculation in Excel so that the computer can do all these calculations and present this amortization table very fast for you. Let's try read this amortization a little bit more. Suppose you want to sell the car after 2 years. What you need to do is to write one check to pay off all the remaining balance back to the car loan company. So you need to know how much is the remaining balance after 2 years. The remaining balance after 2 years or 24 payments is here, $5,447. You can also try to use a financial calculator and figure out all these amortization calculations. Again, in my financial calculator demonstration video, I show you how to do the amortization calculations in your calculator, so please go check out that video. If you are using the BA2 Plus or if you are using the TI-83, those are two different videos, so make sure you are watching the right video for your calculator. No matter what calculator you are using, the first thing is to enter the annuity information and compute for the payment. And once you have the monthly payment calculated, if you have the BA2 Plus calculator, you can use the amort function, enter 2 as P1 and 2 as P2, and then you will see that the screen shows the BAL, the balance, as 9651, which is the 9651 here. That will be the remaining balance after 2 payments or 2 months because you entered 2 here for P2. If you scroll down, and you will see that your calculator gives you the PRN result as 175.15. That will be the 175.15 here, the principal payments. This is a principal payment from your second payment because you entered 2 as P1 and 2 as P2. So from the second payment to the second payment, we're talking about the second payment, and out of the second payment, the principal portion is 175.15, and if you scroll down one more time, the INT you will see is 73.7, which is the interest paid within the second payment. You can also look at the total interest that you would pay during the first 2 years. Now, if we are talking about the first 2 years, that's a total of 24 payments. If you look at the amortization table, the total interest paid during the first 2 years will be all these 24 numbers add up all together. As long as you enter 1 as P1 and 24 as P2, and then you scroll down, your calculator will show you the INT total interest payment as $1,419.53. Apparently, your INT results from the financial calculator is a total amount of interest payments, and a total of how many payments, that depends on the input you have as P1 and P2. So think of P1 as the from the first payment, and P2 as the to part. From the first payment to the 24th payment, all 24 payments included. But if P1 is 24 and P2 is 24, you can check, and then the INT will be only 42.40. That will be from the 24th payment to the 24th payment. Then we're only looking at the 24th payment itself. If you have the TI-83 kind of calculator, it's actually easier or simpler for you. Check out the video and come back, see if you can get the same results. So now we have finished all the topics that we need to cover in Chapter 5. Apparently, Chapter 5 is a long chapter with a lot of stuff and a lot of calculations. We have talked about the present value, future value of uneven cash flows, present value, future value of ordinary annuities and annuity dues. We also talk about the present value of a perpetuity, which is a special kind of annuity. And we also talk about the future value and present value with frequent compounding, which means compounding for more than once a year. And based on that, we also try to figure out the so-called effective annual rate. You need to know how to calculate the effective annual rate based on the compounding frequency and the nominal interest rate, or say the APR. And you also need to understand or be able to describe the relationship between compounding frequency and the effective annual rate. At the end of this chapter, we talk about amortization schedule. So we try to understand the amortization process, and we try to figure out the monthly payment of a loan and figure out how to find the remaining balance, total principal payment, and total interest payment